for C2,
Your auto response keeps texting me about it.
I'm going to text you right now. All right. For C2, this is working with the trig equation and solving it. We've worked with solving trig equations, but just in the realm of a triangle, which in a triangle, you're only going to ever get one answer because all your angles have to be less than 180. So, when we're working with radians, it changes a little bit because you can have multiple correct answers that will make it true because your cycle keeps happening over and over and over and over and over again. So, we're going to look at, let's do a sine one first. So, 10 times sine x, oh, where did I? And then an argument of sine is going to be x minus 0.3. And then we'll set that equal to negative 3.
This is incredibly confusing.
Okay, hold on. I have to address that because you guys, how many times have you guys said that? Like first day we started graphing together, everyone said, this is incredibly confusing. By the time that day was done, it was a little bit better.
Yes.
And the next day was a little bit better. The next day was a little bit better. And then by the time that you took the test, everybody was really good at it. Okay? Most people got 4s, 3.5s, or 4s on that standard. So, yes, everything new that you learn is usually a little bit confusing or a lot confusing at the very beginning, but I don't expect you to know it right off the bat, and that's why we practice it and practice it and practice it. Okay? So, let's start with what we know about solving equations in general. We have to get my variable by itself. But where is my variable?
X.
My variable is x. Where is it, though?
In the argument of sine.
In the argument of sine. So if it's in the argument of things, we have to actually get that something by itself. So we have to get this sine of x minus 0.3 isolated. What's attached to it?
The 10.
The 10. So how do I get rid of the 10?
The 5.
Okay. So we know some stuff about this we can do. So, negative 3/10. We also know how to get rid of sine, because we've done problems like this before. Inverse function. Now, because this is a radian problem, and because now we're going to be asking for multiple answers, not just the first answer you get, but multiple correct answers, we're not going to just do sine to the negative 1.
That's disappointing.
We're going to treat it as, and I think I said this in the video, but arc sine, that's the same thing as sine to the negative 1, but it's intending you to have more than one correct answer, because it's talking about the arc value or the cyclical values of your function. So we have arc sine of sine, and we're going to take the arc sine of the other side.
Is there an arc sine button?
No. We're going to talk about that, though. So the arc sine does the same thing, because it's essentially the same thing as sine to the negative 1. It's going to cancel out your sine on the left side, giving you x minus 0.3. And then over here, we have arc sine of negative 3/10. Now, the reason we use arc sine is because that triggers us to do something else with this problem. Okay? Think of your unit circle. Where is sine positive? What quadrant?
Second quadrant.
Second quadrant and first quadrant. Okay. Which means there's going to be two answers, essentially, that make this true, and then any coterminal answers with those two answers, because you can get two positive answers for arc sine. So with sine, in the unit circle, we're going to have an answer in the first quadrant and an answer in the second quadrant. And so to set that up, we're going to end up showing two solutions here. Okay. The first solution we're going to write as just sine to the negative 1 of negative 3/10. That's going to get my answer, this sine to the negative 1, negative 3/10. If I was to punch that out, that would get me my answer in my first quadrant. And then we're going to have to do something here with that. Okay. To get x by itself, what do I do?
Add 0.3.
Add 0.3. So I'm going to have sine to the negative 1 of negative 3/10 plus 0.3. And then we're in radian mode here, so we're going to go ahead and add 2 pi n to this answer. Now what this does and sets us up is to find multiple answers because this is just giving us coterminals. Remember we were finding coterminals, you just add and subtract 2 pi or 360 or whatever. In this case it's going to be 2 pi because you're working with x, so we know we're in radian mode. And we're going to be using our calculators here to find those answers so we don't have to just keep punching stuff out. This gets me my answer in my first quadrant. Now to find the answer in my second quadrant, the other possible answer to this, we have to take the x-axis over here, which in radian mode is pi, and subtract this answer. So we'd have pi minus sine to the negative 1 of negative 3/10 plus 0.3 plus 2 pi n. This gets me my answer in my second quadrant. Casey, you have a question?
Yeah, I was just wondering what the n meant with the 2 pi.
It just means how many rotations you go. So if n is 1, that means you go around once. If n is 2, that means you go around twice. It's just how many coterminal angles you want.
Okay.
So, in almost all of, the only one that's not going to happen with is tangent. Tangent's only going to have one line that we have to put into our calculator to find all our answers. We'll talk about why. But sine and cosine both have 2 lines that we have to put into the calculator to find all the possible solutions. Andrew, you have a question?
Yeah.
Mhm.
The second quadrant.
Mhm.
Why do you put pi in it?
Because this gets me my first answer. So let's just say, for example's sake, the first answer ends up being 30 degrees, which is not going to be because we're in radian mode, but let's just work with that number. Okay? So 30 degrees. We would need our other answer in the second quadrant to have the same reference angle in order to give us the same value. And so your reference angle here would have to be 30. And so you'd have to take pi, and if you subtract the angle, you would get the same space there. So whatever that angle answer is.
Okay.
Like with cosine, because you're positive in the first and the fourth quadrant, that's why we do a plus value and a negative value, because that would give you your values in the first and fourth. Because it's basically finding how far you go this way to get that angle, and then how far you would go this way to get that same angle. But then that gets you the answer in the first and fourth. Now, so that you don't have to punch all of this out by hand, this is where we go to our calculator, and you go to y equals, and if you have a calculator, you should probably follow along here. And we're going to put in, well, first, make sure you're in radian mode, please, because that'll screw up your answers if we're not in the right mode. And go to y equals. And then we're going to punch in the lines that we see there. So sine to the negative 1 of negative 3/10 plus 0.3 plus 2 pi. And then instead of n, you're going to use x here. And x, our variable, just represents how many rotations that you're going around. Okay? And the next one will be exactly the same, except you'll have pi minus sine to the negative 1 of negative 3/10. Whoops. Plus 0.3 plus 2 pi x. Okay. Once you have both of those equations or answers in there, notice we haven't punched anything out to decimals. We just left it as is, and then we let the calculator do the work. That's going to give you the most exact answer because you didn't do any rounding. Go to your table, which is under second what? Second graph. And then if you have answers there, clear them out. Actually, you know what this is. Okay. And we're going to start putting in numbers. When we put in numbers, the numbers represent our rotations. Okay. So we usually start with 0. You can go negative rotations, but like for example, for this example, and mostly for most problems that you're going to look at of this type, it's going to ask for the first 5 positive answers. Okay? So is this going to be an answer that we write down? No.
Wrong.
Well, this is a negative answer. So we would start with this answer. But because this is a 3.7, just to make sure that going in negative rotation won't get me another positive answer, I'm going to put in -1. So if we went backwards, would we still get a positive answer? No in this case. So 3.746. I can come check these in a minute. So 3.746 is going to be our first positive answer. That's when you don't go around any rotations. So then what would be the next thing that we put in? Add another 2 pi, right? So that's just putting another 1. This represents 1 rotation. And I get 2 more positive answers. So we get 6.278 and then 10.029. And then if I go around another rotation, that would mean I've gone around 2 whole rotations or 2 whole cycles. And that gives me my last 2 positive answers. So 12.562 and 16.313. We'll write those down. Okay. Before we're going to do another one of these. I don't know if there's extra space. If you flip maybe to example 5 and draw a line, you could have at least those examples in your notes. But we'll do another sign one just so that you have another one that we've talked through. Let's go with, if you flip to the end, C2, example 5 at the top. We don't need the whole page for that example, so you can just draw a line. Okay, so sine of 2x plus 4 minus 3 equals. Well, we'll go plus 3 equals 1. Okay, so we'll solve this one. Ethan, did you figure out what you did?
No.
Alright, so treat this like you would a regular equation. You need to solve for x. X is stuck inside the argument of sine, so we have to get that sine of 2x plus 4 by itself. So Andrew, what's the thing I should do?
Add 3 or subtract 3.
Subtract 3. So if I subtract 3, I get 4 sine of 2x plus 4 equals negative 2. And then Josh, what would be the next thing that you do? Divide by 4. So can I reduce that?
1/2.
Yeah. If you can reduce it, please do it. Just makes your life a little bit easier. Alright, then at this step, we're going to take the arc sine of both sides. Now, if I just wanted one answer, that's when you would just do sine to the -1 and go from there. Because I usually ask for the first 5 positive answers to make sure we're getting all the possibilities, a lot of the possibilities, you're going to want to do the arc sine of both sides. No, I just cut off the screen. Alright, so we're going to take the arc sine of the left and arc sine of the right. And Calvin, what does this arc sine and this sine do to each other? Cancel out. So you're just left with 2x plus 4. And over here on the right-hand side, you have arc sine of -1/2. Now, before we convert this, let's go ahead and get x by itself first this time. So leave it as arc sine right now before we replace it with what it means. To get x by itself, we're going to subtract 4 from both sides. And then do what? Divide by 2. Now, when you divide by 2, that means you divide everything by 2. And so, to show that arc sine of -1/2 is being divided by 2, I'm going to stick a 1/2 out front. And this is kind of what you have to do when you're dividing by something. And the arc sine's already there. And then negative 4 divided by 2 is what? Negative 2. Okay, so you divide everything by 2. Now, once the x is by itself, that's when you can replace arc sine with definition. So maybe that's a better term to use. The definition of arc sine is that you have sine to the negative 1, negative 1 half, plus 2 pi n, and then pi minus sine to the negative 1 of negative 1 half, plus 2 pi n. So, to show that, when I have this, then I kind of expect to see 2 lines of equation here to give all the possible answers. Notice the 1 half is going to stay out in front of the parentheses because this is what we're replacing in the parentheses with the definition of what arc sine means. The first part of what arc sine means, to get my answer in the first quadrant, is sine to the negative 1 of negative 1 half. And then because we're looking for all our possible answers, we have to add 2 pi n, close the parentheses. And then it's also equal. This gives me my answer in the first quadrant. And then to get my answer in the second quadrant, it's going to be pi minus sine to the negative 1 of negative 1 half plus 2 pi n minus 2. Okay. So I know there's lots of stuff going on there, but what we've replaced is the arc sine of negative 1 half. And that's been replaced by the 2 definitions, first quadrant and second quadrant. Okay. And then the easiest way to figure out what your answers are is to put both of these into your calculator and then use your table to run your different cycles so that you don't have to put in multiple values multiple times. So, might be good to pull out your calculator and do this along with me here. So instead of 1 half in as a fraction, just put in 0.5. If you did put in a fraction, it would be fine, but it makes it a little bit nicer. So 0.5, and we have sine to the negative 1 of negative 1 half plus 2 pi n. So we're just going to use x in that case. And then we have to close that parenthesis because remember 1 half is out in front of all of that. We're not multiplying the number at the very end of this, that negative 2. That's not multiplied by 1 half. We already took half of that, so we don't want to do it again. And then we're going to subtract 2 from the end. Next one, 0.5. And then in parentheses there, we have pi minus sine to the negative 1 of negative 1 half plus 2 pi n, close the parentheses, subtract 2. And just to let you know, we do practice the standard a lot. It's not hard once you get used to it, but there's several steps. I mean, getting x by itself should be fine for us. It's putting the stuff in the calculator that's usually the hang-up. Because a lot of stuff, if you just put something in place, it screws up your answers. So, we practice a lot. Alright, and then where do we go after we get those in? The table. And the numbers that you put in for your x represent rotations. Okay? And I usually ask for the first 5 positive answers. So notice when I put in 0, when I put in 0, I get 2 negative answers, so those are not ones that I'm going to write down. I'm going to put in 1 rotation. I get 2 positive answers there, so those would be the first 2 answers I write down. So x would equal 0.879 and 2.974. Second rotation gives me 2 more positive answers, so 4.021 and 6.115. And then I have to go 3 more rotations, or 3 rotations total to get my last answer, which is 7.163. Okay, so this is sine. Now, let's just, hypothetically, if it was degrees, so instead of x, I had theta. what would change about your answers here?
They might be 3/8.
So instead of 2 pi n, I would have
360.
360 n, and instead of pi, I would have
360.
80. Yeah,
180. Why would you have 180 there?
instead of pi.
2 pi is
Because pi and 180.
Gotcha.
Yeah. So pay attention to what variable you have at the beginning, but the setup is the same. It's just you'd have to have 360 instead of 2 pi. All right, let's go back and flip to example 3. We'll do a tangent one, and we'll probably do another tangent one before you get practice on. You guys okay? All right, so for the tangent one, and not to secant, cosecant, cotangent, we're just doing the 3 main ones. Let's go with plus 4 tangent of 2 theta minus 1 equals, sorry, I had to make sure I picked the right number here, 10. I don't want to get a solution. All right, so, Kenny, what do I have to get by itself?
You have to get tangent 2 theta minus 1.
Okay, so I got to do that by itself first. All right, so, Ethan, walk me through it, please.
First you subtract 4, right?
Yep.
Decalculate 2 and so you can add it.
And then?
Then you divide by 4.
All right. So 6 divided 4 gives me what?
3/2.
3/2. All right. And then what would we do to solve or get rid of the tangent?
Is there an arc?
There is an arctangent. So that is what we're going to do to both sides, is arctangent. Arctan of both sides. Arctan and tan then cancel each other out. You can use 2 theta minus 1. And again, we're going to keep arctan until our theta is by itself, and then we're going to convert the arctan to its definition. Okay? So, Evan, walk me through how to get theta by itself.
You add 1 to the other side and then, or to both sides actually, and then you divide by 2.
Good. Add 1. And then when you divide by 2, everything has to be divided by 2, but how do I show that with the arctan?
Write 1/2.
Yep. Write 1/2 in front. And then that 1 is being divided by 2, so you have to have it there. Now, arctan is the only one that you're not going to have 2 things you have to plug into your calculator. You only have to have 1.
Yay.
Yes, and I'll show you why. Because where is tangent positive? In the first and the
Fourth? No, third.
third. Okay? And what's special about the first and the third quadrants is they are half a rotation away from each other. So instead of adding 2 pi n, we're just going to add pi n and add a half rotation, and that'll get us to this angle in the third quadrant. The other ones we have to have 2 different equations because they're not half a rotation away from each other. They're not a quarter rotation away from each other either. So that's why we have to have 2. For tangent, we only have to have 1 because adding half a rotation will get us the other angle in the third quadrant. And then adding another half rotation will get us back to the coterminal angle in the first quadrant, and then the cycle continues over and over. So, to show what we're doing here, the arctan definition is going to be tan to the negative of 3/2, whatever value that is. And then, are we in degrees or radians?
Degrees.
We're in degrees. How do we know if we're in degrees or radians?
Theta.
Theta, yeah. So we're in degrees. Instead of adding pi n, we're going to be adding 180 n. Close parentheses there, because that 1/2 is out in front of arctan, and that's what we've replaced arctan with, right there. And then add 1/2 to the end. Okay, so for tan, we don't have to have 2, we just have to have the 1. Just make sure that you're adding half rotation, and you'll call it good. So, go back to y equals. I want you to try to put that in yourself first. And on your screen, so before we write down the answers on your screen, get the first 5 positive answers. your calculator in air, we feel like you have your answers. I was gonna make you do some other stuff just in case you kept falling apart.
I got this.
Okay, we've got 4. We'll wait for a couple more people here, and then we'll check our answers.
Calvin, why are you so... Oh, wait, hang on. I got provided that degree note.
Oh, did other people forget that?
Oh no. Oh. Man. Gosh.
Good catch, Kenny.
Where is it?
Degree.
I can't get
I
it.
have to rewrite all these stupid values.
That's why I said before you write the test.
Table. Show me the table.
Kaboom.
Table.
Good job, Calvin.
Okay, got it.
L point six five. Well, we don't know if they're right yet.
Dude, you should have seen Hank throw this championship right. It was like, it's a 7 and a half.
I wouldn't doubt it.
It was huge.
Alright, so the answer that I've gotten, which hopefully is the answers that you have also gotten, those 5 right there. 28.655, 118.65,
I didn't get those.
108.65. Are we not getting that?
So the answers are just the positive ones?
Just the positive ones.
Cool.
And we'll ask you usually for the first 5 positive answers. But just to make sure, if I put in 0 and it's a positive answer, I always put in a negative rotation just to make sure there's not 1 if you go backwards. Because sometimes, depending on if you're multiplying by a weird fraction or something, there is. Josh?
So what do these answers like mean?
So our answers, like you've been doing this kind of in C1, where you graph the function and then you graph a straight line and you find the intersection.
All my answers are off by 20.
So that's basically what it's meaning. But we need to know how to find multiple answers algebraically when we, because we could graph and find intersections, but for this it would take
So these are like
longer.
intersection points
Yes.
on a graph.
Yes.
Calvin.
This is, like if you put that into an equation, or into a
What?
All my answers are
y
off by
equal,
20.
this would be where it intersects. Straight line. Okay.
I have something to go on with here.
Did we
21.13.
That's
Yep.
funny.
Oh dear. Any questions on those?
Nope.
Okay. Yes.
Why were there no, why were the y2 not, applied
There was
to...
one equation.
There should be no y2 here because with tangent, because you only go half rotation, you don't have to. If you didn't
Alright,
really got the
yeah,
other
I
one.
did it with no, but I added like a 180.
You don't have to though with tangent.
Alright.
Because
Yeah, I just got a bunch of negatives for that. Pretty much all the
yeah.
same.
Yeah. Alright, let's as we didn't do a cosine together. You did one if you did your notes. But as a refresher, because I'm going to ask you to do some whiteboard stuff with, so I want you to have some examples to follow.
Okay.
Let's do one cosine together and see how we do.
I fixed it.
I don't know
I
where
had
your
3 over
calculator
12
is
instead of 3 over 2.
Look how long it is.
What? Oh, she did.
This isn't for my class next year.
Okay.
This is for the ladies who are missing.
What?
That's not
For
nearly
Brian.
fun.
Brian was here.
I have to watch this entire meeting.
And somebody else who went to, who else is missing?
Evan here?
And who else?
Evan's here.
Yeah.
Hi, Evan.
Somebody else is missing.
Will should watch it too.
Okay.
No got last.
No,
They
you
got
guys got last. Wild example. Everything else only had like...
Ethan, considering everyone you had, you
The
did
total for the week was like 6.
Okay.
Except for last.
Write it down.
Considering how many people you had all week, you didn't
I mean by don't replace it with, like, write arc cosine. Just don't try to replace it yet.
Oh.
That's what I meant. Sorry.
Oh, so you can go all the way. Okay.
Yeah, I'm
You're
sorry.
fine, take your time. Keep going.
Are there two C's in arc cosine?
Yes. Okay. That's what you should have. We do okay?
Yeah, I just realized I never.
Okay. So now it's replacing arc cosine. That's what our next job is, just like all the other ones we've gotten to this point, and then we have to replace it with its definition. So where is cosine positive? First and
Fourth.
fourth. So think of that as a positive angle and a negative angle. And that's what our definition is for cosine, to solve for our many answers here. So we're going to have two lines that we put into our calculator for cosine. The first one is going to be a positive cosine to negative 1 of your value.
I think I'm gonna look the tangent.
Are we going to be adding 2 pi or 360?
2 pi.
2 pi.
Well, you said it.
Okay. And then our next line here, that's our positive, so that's going to give us our answer in our first quadrant. And then the answer in our second quadrant is going to be negative
Wait,
cosine to the negative 1.
what about the pi?
You don't use it.
What?
Really?
What do you mean, what about pi?
It's like for the
Instead of
Y2.
sine, we put a pi in front of the cosine.
For
Right,
Y2,
so the
right?
pi represents starting at the x-axis over here and subtracting so you get an angle in the second
First
quadrant.
cosine.
This
Okay.
gives us an angle in the fourth quadrant because instead of going positive angle, you go negative angle.
So is that a negative cosine?
Yes.
Negative
So
cosine,
negative
negative
cosine.
1.
So it's just positive cosine, that gives me my answer in my first, and this gives me my answer in my fourth
Gotcha.
quadrant. Okay? And then we go to the calculator and put those in as our two lines of text here. You're going to get more exact answers if you use 1/3.
Yeah.
So I'm going to put it in as 1/3.
Are there two equations here?
Yep.
Oh yeah.
So we have 1/3 cosine, cosine to the negative 1 of negative half.
Is it negative or minus cosine?
I'm putting the positive one in first.
Oops.
Okay. Plus 2 pi n parenthesis
That sounded
plus
good.
1/3. And the same thing for the second one, except we're going to make it a negative cosine to the negative 1. Whoops, and I forgot parentheses. Okay. Now, another mistake that happens often is that people get to this point and then they forget to change their
Calculator.
mode. Yes.
Good
So make sure
call.
that your mode is in radian mode.
So.
And then let's go to your table and see where we're at.
Okay, where's my mode? Okay, I can't even go to my table because it says error.
Because you're using a subtraction instead of a negative. Now try it. There you go. Okay, so those are the answers that you should be getting. Going in negative rotation gives me negative answers, so I want my first five positive ones, so it'll be those 5 there. Is that what you guys are getting?
Yep.
Yeah. Oh yeah.
Okay.
Yes.
Go ahead and write those down so you have them in your notes.
Wait. I got the right answers for the first column, but I think I
Okay, go ahead and get whiteboards, markers, and rags, if you would.